Morning, everyone. Morning. All right, Dreamforce Day 3. You all have a good time at Dreamfest last night? Yeah, oh, forget about that. The real party starts now. We're talking about Heroku today. So this is a session for people who know Force.com, developers who've been working on the platform for some time, and are happy with the comfort, the familiarity, the safety of working in Apex. So you like all of the declarative tools, the fact that you can build solutions and customers can customize them to their own heart's content without your input. So they can build their own processes on top of your code, and they can add their own custom fields. And but you also have all the advantages of Salesforce, who are building a platform that has massive uptime. And they're also delivering releases 3 times a year. You're getting really cool features like encryption at rest and single sign-on, stuff that would take you ages to develop, but is industry standard, so you can just take advantage of Salesforce doing the work for you. But at the same time, you might be thinking, maybe there's another way. Maybe the grass is greener somewhere else. You've got colleagues working in other technologies, or you speak to your friends and they're working on cool new languages and all of the modern tooling that you wish you could maybe have a go at that yourself. Maybe you've never tried Heroku before. You've always wanted to, but been too shy. Or maybe you've dipped your toe in, but never really committed. If that's the case, this is a session for you. We're going to be doing some code. We'll show you detailed code. Please don't be scared. It's fine and good. If you're a developer and you're wondering what Heroku means for you, and hopefully we'll have something for you in this session as well. If you've just wandered in because there's a gap in your agenda, stick around. Hopefully we can entertain you as well. So enough about you. Let's talk about me. I'm David Frudd. This is my colleague Brad Slater, and we are both developers at Financial Force working on the research team. Financial Force is an ISV. We've been around for a while. We build different solutions, up until now entirely on Force.com. So our flagship product is accounting, but we deliver other solutions like PSA, revenue management, human resources, all of these things that work together, integrate with each other and with Salesforce CRM to give you a complete back office solution. But lately our focus has been on Heroku, which we see as a way of releasing some of the pressure, getting through some of the high volume use cases that Apex just doesn't cut it for. So this is what we're going to be talking about how you make that leap, cover one of the sample apps that we've built, and then go into some of the principles behind that sample app. So we'll talk about the architecture and show you some of the code. So it's not smoke and mirrors. This is something you can really take away and play with today. And we'll show you some of the lessons we've learned along the way and how you can get started with Heroku. So let's make the leap. But before we do that, anyone ever encountered governor limits before? Everyone? You're in a session called Beat Governor Limits. Everyone has hit governor limits. In this case, we're trying to create a contact, but we have a problem. Someone in this org, not naming names, has added a trigger, and it's just eaten up CPU, and Salesforce has killed that process dead. So, governor limits. Has anyone here ever had to write code which has more effort put into describing the problem and trying to work around governor limits? Has anyone ever written code that they feel dirty about and they go home and lay awake at night worrying about what they've done? Governor limits are there. They can be a pain in the neck, but they're just a vital part of this platform. The good thing about Salesforce, and Force.com specifically, is very democratic. So hobby developers who've been throwing together applications up in their bedroom, they have applications that are competing for exactly the same resources as all the apps that have been built by professional development teams have gone through QA and user acceptance. So we're all competing for the same resources, and the governor limits are there to stop us from getting rogue apps hogging all the resources and giving poor user experience. But there's another way. We can go off-platform. So governor limits There's many. If you wanted to print out this documentation page, this is just a list of links to different kinds of governor limit, and that'll fill you 7 sides of A4 easily. So we might want to build an application that isn't on Force.com. There's many ways of doing this. We can build it on-premise, but let's not even talk about that. We're going on the cloud. There's lots of different ways of building your cloud software. There's different platforms out there, mature platforms that are offering compelling solutions. So Google and Microsoft and AWS. And Heroku, there in the middle, is built on top of AWS. So it's not really anything special. It's something that you can use to build applications without using Force.com at all. So choice is a good thing. You can build applications in Heroku that integrate with other systems that aren't Salesforce. You can build solutions on AWS that integrate with Force.com. In the end, we chose Heroku for talking to Force.com, partially because it's really easy to use. There's a low barrier to entry, and it's really easy to scale things up, add new extensions, and just work with. You don't need a dedicated cloud ops team. And the other really compelling reason is that Heroku and Salesforce, it's part of the same platform. We're going to talk about the Apex side, all the declarative things, all the custom objects, all of the Apex code as Force.com, just to help disambiguate. But it's part of the Salesforce platform. Heroku started out as just being for Ruby, but now it supports all of the major languages. And they were acquired by Salesforce many years ago, and the relationship has historically been loose, to say the least. But you can see that they are bringing those things closer together, and with technology such as Heroku Connect, and with all of the emphasis from, if you've seen any of the demos in the keynotes, they're using Heroku all over the place, and it's part of the same platform. So if you build on Heroku, you can expect to benefit from that close relationship between Salesforce and Heroku. So why might you want to move over to Heroku? There's many reasons. We're going to talk about 5. If it's a question of scale, if you want to get through more data, or if you want to store more data than Force.com allows or is reasonable within price constraints, then Heroku is a really good, compelling place to take your processes. You might want extra control, so you might want to be able to scale things up on your own. You want to add more dynos. You want to have more control over the delivery process. So Force.com is difficult to push packages out to customers. If you're trying to do push upgrades, you can find lots of challenges along the way. But with Heroku, it's really geared towards continuous delivery. You might be looking for a better developer experience. So being able to develop code locally and knowing that the code you push up onto Heroku has complete parity with it. Using modern development standards like debugging and linting. Those are all really good things that make you more productive and mean that you can focus on delivering code that solves real problems. You can also enjoy the ecosystem, not just the ecosystem of using non-Apex languages, all the libraries and packages that are out there, but the ecosystem on Heroku, which has its own app exchange and lots of different add-ins that you can choose to augment your app. And finally, you have a choice of language flexibility. So you can choose whichever language suits the skill set of your developers, or you can choose a language that suits the problem you're trying to solve. So maybe there's a really good library that you want to take advantage of that solves your business use case, which if you try to do in Apex would just be really difficult or perhaps even impossible. So you have flexibility over your language, and not just the flexibility to choose which one language you want to use. You can build apps that have multiple languages and build some sort of microservices-based architecture where different parts are written in different languages, and Heroku just supports that really easily. So we're going to be talking about prime numbers. We built a sample app around prime numbers, not because it's some amazing business use case. This doesn't have any real relevance to business apart from it being good for encryption. Prime numbers are great because let's just remind ourselves what a prime number is. It's a number that's divisible by itself and 1. Over here, you've got an animation. You can see if we wanted to find all of the prime numbers up to a ceiling, in this case 120, we can just work our way up and cross off any multiples of any of the prime numbers we've encountered along the way. As far as we know, the set of prime numbers is infinite, and crucially, the problem gets more and more difficult to solve as you get higher and higher scales of numbers. So I'm not an expert in prime number theorem, but I don't need to be because there's a library on NPM that solves this problem for us. So if I ask the isPrime library, if this number is prime, it'll just tell me yes or no, and I can worry about writing that code back to force.com without having to solve that problem. So we're going to have a quick demo. So, Brad, if you would drive. Just escape. That's it. Cool. So I start on the second tab. Can you go to the second tab, please?
Okay.
Cool. So we've built an open source repo, which you can take away today. All you have to do, go to GitHub, search for df17 Heroku compute. If that's too long, just choose your favorite 2 words out of that sentence, and it'll find it. So there it is, just the one result. And if we scroll down, there's a README, there's some wiki pages to help you get started with it, and even better, there's some one-click deploy buttons that you can use, so you don't have to set up a local development environment. If you want to play with this app straight after this session, you can go to this repo, click those 2 buttons, and have a play with it. So switch over to the third tab, please. This is what you'll find. We have over here a lightning component, top right, which just has a number spinner and a button, which will send our request over to Heroku. And on the left-hand side, we've got a report. This has just been built using the out-of-the-box report functionality within force.com. So the reason we've built this app is we want to demonstrate how to build an application that spans these 2 platforms. And we've intentionally built it taking shortcuts, using vanilla code as much as possible. So we haven't got any dependencies that aren't publicly available. It's just to demonstrate things. We're doing shortcuts on authentication, like we're just reusing the current user's session ID. If the current user logs off, it'll break. We know that is a limitation, and we know ways of doing that better. But for the sake of simplicity, this is just a vanilla, as simple as you can get, application that lets you focus on building apps that span Heroku and force.com. If you want to do something more sophisticated, we do offer other libraries that will solve some of those common problems for you, which Brad will talk about shortly. So let's get into the demo. What we're going to do is generate 10 prime numbers. So this is going to send off a request to Heroku, which is going to fire back a platform event that drives that toast notification that's told us we've calculated 10 prime numbers and we've sent them back using the bulk API. If we refresh this chart, which says it's 17:13, it's still on UK time, much like me. It will probably wake up at 3 a.m. tomorrow. We've got 10 prime numbers. Nice distribution there, which isn't that exciting. So let's push this to its limit. Let's fire in 10,000 prime numbers, which is the limit of how many records you can insert in one go using the bulk API. This will cope happily up to 50,000. I've tried it. I haven't pushed it further than that. You might want to try that at home. So we completed the calculation really quickly. Heroku got through that work. But now the bottleneck isn't the calculation. We have all of those prime numbers in memory, and we're trying to insert them into force.com. If you refresh that chart, Brad, you can see that these prime numbers are getting inserted gradually. The bottleneck is still force.com. We're subject to the bulk API limits, which is inserting these records slowly. Okay, that concludes the demo. So switch back to the slides. But then top right. Okay, so just a little recap. You can find that repo and have a play with it if you go to this address. And this is an open source SFDX project. If you haven't had a chance to play with SFDX yet, or with platform events, then not only is this app good for playing out with Heroku, you can try out SFDX and platform events too. We've tried to keep the Force.com side really lean. We're not trying to teach you Force.com. I'm sure you're familiar with it. But what we have done is use Node.js for the Heroku side. We like Node, but if you want to use Java or any other language, then feel free. So with that, I'm going to hand over to Brad, who's going to take you through some of the concepts driving that demo.
Okay, so first of all, we need to speak about Heroku Dynos. A dyno in Heroku is kind of a container for a process, really. There are two types of dyno. There are web dynos, which have a port exposed, which can serve web requests, web traffic. And there are worker dynos, which do not have a port exposed and run worker processes. The sample app uses two dynos, one web dyno and one worker dyno. And these are instances of a web and worker dyno, and you can have multiple instances. You can scale out, you can scale up, you can increase the size of the dyno, etc. So if we look at the architecture of the app, what we basically find is that we have the Lightning components that you've seen in the demo, and we have the Force.com code in Apex backing that. We have a Heroku web dyno, which is going to handle HTTP requests, and we have a Heroku worker dyno, which is going to calculate some prime numbers for us. The separation between the web and worker dyno is handled via RabbitMQ, the message queue, which we'll be using to send messages from the web to the worker dyno. So when the user presses the UI button in the Lightning component, a request is made to the Force.com backend via the Lightning controller, which makes a HTTP request to the web dyno, which will authenticate back to the Force.com server. Now, in our example, this is just as simple as taking the session ID from the request and the referrer URL, but we have more complex authentication, which we'll speak about a bit later, which you can have a look at. It will then publish a message onto the RabbitMQ message queue. And after that, it will immediately respond to the Force.com side saying, OK, the request processed OK, and we'll get the call back in the Lightning component, which says request sent or whatever. Asynchronously, from the message queue, the worker dyno will subscribe to the event, and it will hear the event, and it will compute some prime numbers. While it's doing this, it will make REST requests back into Apex using the session, and these will create platform events, which we're using to show the toast notifications that you saw in the UI. So you can see those, that's user visible feedback. And when we've kind of finished the process, the prime numbers appear in the chart which we're refreshing. So to have a look at some code, this is the Apex side. I'm sure you're fairly familiar with this. We're creating a HTTP request, fairly simple. We're adding some authorization and referrer headers for authentication. And we're adding some stuff to the body of the request in order to tell the Heroku worker and web dyno how many primes we'd like to calculate. So now we move on to the Node stuff. As Frud said, don't worry if you're not a Node.js developer. We're going to be talking about high-level concepts. You can feel free to have a look in your spare time and learn a bit more around the edges. So we're using Express as our web server, which is a fairly common Node dependency. And we're just going to add a few simple bits that add some fairly rudimentary and default authentication and best practice security features here. We're going to use an authentication middleware, which is just a Express middleware, which checks that the session ID and referrer URL have been added. And we're going to add a route to our server, which gives us the kind of endpoint that we're making the post request to. So if we move on here, we're now looking at the handler for that route that we added. And we can see all we do is just publish a message onto our message queue. Fairly straightforward. Then we immediately send back a 200 success response. And in the event of an error, we will send back a 400 error response. We now move over to the worker. So this is after the message that we just published in the web has moved through RabbitMQ and has been heard in the worker. And here you can see the worker subscribing to that event. So we can see we're subscribing to a primes requested event with a handler function that we created. This is the code that calculates the primes for us. So we've got a way to push prime objects, and you'll see the underscore C's, which may be familiar to you. You can see we're creating actual objects. And we're using JSForce to insert some of these primes. You can see here we're using the events, the platform events that we're inserting to say we're starting to insert some prime numbers, and that's the bit that the user gets the visual feedback from in the Lightning UI eventually. We then go on to actually run the insert primes function to actually insert the primes. Then we fire, one second, it's gone too far. Then we fire another event saying we've successfully inserted these prime numbers. In the event of an error, we'd fire an event saying we've got an issue inserting these prime numbers. And all of these events that you can see are visible to the user in the Lightning UI, like I say, via the toast notifications. So to move forward from the kind of deep dive and looking at the code, the sample app web dyno, as we've said, uses Express, which is a well-known web server. It uses Helmet for security, and it has a simple single route for handling post requests to calculate prime numbers. It could have multiple routes. We could do multiple things. We could have multiple different routes on the web dyno. We could have multiple event types, and we could have multiple workers or the same worker handling these multiple events. It could have a mixture of secure and insecure routes, so we can add different authentication like schemes to different routes if we want to. So going on to authentication, to verify that the user should be allowed to make a request, we check force.com recognizes the user and the org. And as I say, the simple way we're doing it is we're just using the session ID to call back. If the session ID is not valid, then the callback will fail, and that'll be kind of our error. We do have much more sophisticated authentication systems. We have an open source library called Orizuru, which we'll show you on a slide, which has an authentication component, which will do connected app, OAuth, JWT assertions via a certificate, which is what we're using in some of our more advanced demos. As must be apparent by now, we're using an event-driven architecture, so all of the work that we perform in Heroku is asynchronous, and we like that because we don't believe in hogging the web dyno. We believe that the web dyno should be handling and serving web traffic as rapidly as possible. We believe that the kind of work done and the callback into Salesforce should always be asynchronous. In terms of scaling up, we could be scaling up our web dyno. So if we've got many requests coming in for small numbers of primes, say, we can scale our web dyno up to cope with the increased volume of requests to run multiple instances of it. Or if we had a small number of requests coming in for many primes at once, we could scale up our Heroku worker dyno to handle the large number of primes. And these things can be scaled independently, so there is no kind of bottleneck for either use case. We can be very flexible about how the kind of work is done. So we don't need to just recreate the kind of paradigms on the force.com platform, such as like batch apex and queuables. We can be much more kind of business use case driven in our process in how we develop our code, which we see as a big advantage. And we think that you should do really small chunks of work often, which helps you cope with failure scenarios, because you can kind of, if you've got small chunks, you can know where you're at in the process and kind of replay and stuff if you fail at any given point. So moving on to some tips and tricks that we can't really demo. We've got some insights that we've gained from using Heroku for quite a while now in research. We believe in Heroku pipelines, which are a Heroku feature that allow you to push your code to kind of feature apps, to staging apps, and to verify that everything works before you push to production. They work very well with the continuous integration and delivery methodologies, and we highly recommend those. We believe in kind of managing our dependencies really carefully to ensure that what we're testing in development is what we're running in production. So we make sure that we lock down the versions of any dependencies that we use in NPM, in this example, in Node. And we believe in local development and testing in as close to a production environment as possible. So we believe in using Docker. And we sometimes use Postman if we're running stuff locally to to mimic the Apex call out from Salesforce locally. One really important thing when you're kind of building and deploying apps is that you need to know what's happening in the cloud in real time. So we believe in instrumentation for your apps. We believe in good logging, using good logging frameworks. Our example, I believe, uses Debug Plus. We also believe in taking advantage of the kind of third-party tools and plugins available in Heroku to kind of monitor your processes and see how they're doing. We think that continuous integration and delivery are really important because we always try to stay ahead of the curve, ahead of any kind of known vulnerabilities, ahead of upgrades. If something breaks, we want to fix it instantly, pretty much. We want a patch and a fix out within hours, which you can't really do on Force.com, but in Heroku, you can. So we recommend all of this, like aggressive updates, following security best practices, subscribing to change logs, etc. There's also one other thing to mention in terms of the kind of like security integration stuff, and that's Heroku private spaces. We think Heroku private spaces are good because they can give you like isolation of process, and what it is really a container for all your apps to run in, which means like low latency connections and again increased security. So we've really only talked about compute processing as part of this demo, and we wanted to keep it really simple. But there are many other use cases for Heroku, and we plan to go into many of those in more detail as we continue. So we can persist data in databases in Heroku if we choose to. We can use Postgres. We can integrate that with Salesforce with Heroku Connect. There are other choices as well. We can also use more sophisticated messaging systems. So the demo you just saw was with RabbitMQ. But we have Kafka as well, which we think is really cool for kind of giving us a streaming kind of event-based system that allows us to do some really complex things and like really dictate how we parallel process and how we serial process stuff in complex use cases. That's been really great for us. We can also serve UIs as well. So we could serve React or Angular UIs. We could use templating engines. And we could do stuff like this via Canvas apps into Force.com. So yeah, there is that use case as well. So you can get started today. Like Shrud said, we've got our app available. You can go and check it out. You can take it locally. You can change it. You can deploy it. You can try it out. You can deploy it straight from GitHub if you'd like to, if you just want to see it working. So you've got a few options there. You can fork it into your own Git repo. And all the time we've been talking about more advanced libraries and kind of next steps. So this is Financial Force Orizuru. It will streamline development in Heroku. It's a framework for messaging across web and worker dynos. It's a framework for specifying how callouts are made from Apex to the web dynos. We use Avro schemas for loads of stuff. And we can generate stuff like the Apex transport code that makes the callout. We can do loads of stuff with Orizuru. It can handle authentication via certification in connected apps, and the tooling can push authentication both ways. It's quite a good productivity tool if you're just starting out as a developer, and it can generate simple boilerplate apps for you to play with as kind of templates. So thanks for listening, and we're going to move on to some Q&A now.
So you're just going to let us off that easy? Oh, great. Can you come to the microphone in the middle? Thank you.
So in your case, you guys use Heroku, but if I was using something like Azure, could I have gone with the child processes in Node rather than having a worker and a web thread?
Can I talk about?
Yeah, so was the question about child processing in different kind of cloud compute?
So let me put it this way. So if I compare child processes performance with Heroku web workers and web dynos and worker dynos, how does it fare?
How does it compare?
Yeah.
The performance between web and worker dynos. Right, so performance is going to be an interesting topic to discuss. It's heavily dependent on what language you're running, what you're doing, how many requests you're serving, etc. In terms of performance recommendation, the only thing I could really say is we use web dynos for handling web traffic and responding as quickly as possible. We try to be really lean with the code that we write in web dynos to ensure that we're just taking a request, passing it to a queue somewhere so some worker can do some work and immediately responding. And that keeps our web dyno free to keep doing its job essentially and keep handling requests. In terms of performance of worker dynos, that's going to be heavily dependent on language choices, the use case, what you're doing. But the fact that Heroku allows the kind of scaling out and up in terms of dyno size and number of dynos running generally means that we can do anything we'd like to do within, obviously, the kind of cost constraints that we may or may not have. So, yeah, that's all I can really say, to be honest. It'll depend whether you run in Java or Node. We've tried both. It'll depend heavily on your use case as well.
Does that answer the question?
Yes.
Yeah, great.
Just to get a better idea of what can be done with Heroku, like what do you guys in Financial Force do like to connect the apps or like some use cases that you actually use in real life?
Yep, so it's very early days. The result of this is, this is the result of doing lots of research and POCing. So we haven't got anything that's using it today, but we have a number of processes in the pipeline for complex compute. So things that you need to do serially on Apex. I don't know if we can say much more than that.
No.
I'm not sure if my hands are a bit tied, confidentiality-wise. Oh, that's all right. As long as it's not being recorded, that's fine. The spring release, keep your eyes open on the next Financial Force release. We'll be announcing some of those things. Thanks. Okay, well, thank you very much. If you want to come and find us after or get in touch on Twitter, please do. Thank you.